everyone, my name is Milovan and I'm a PhD student at Faculty of Mechanical Engineering in Belgrade. Today, I will talk about the effect of field orientation and field angles on input toughness of PET G FDM material. This topic is related to my dissertation, where the goal is to investigate the influence of adding short carbon fibers to PET G material in aim to obtain information. Does that adding of short carbon fibers improve material properties, to be exact, input toughness, and all that in different temperature range, from room temperature to cryogenic temperatures. Table of contents. I will talk basic things about FDM, our experimental approach, specimen preparation, and testing results. I will do comparison between PET G and PET G plus short carbon fibers, and after that, I will draw some conclusions. FDM, fused deposition modeling, is manufacturing process widely used for prototyping. And basic idea behind FDM is using thermoplastic filaments like ABS, PLA, PET G, or nylon, and heat it until melting point, and then extrude it to the nozzle layer by layer to build up desired shape. This process is simple, low cost, and versatile, which is compared to the regular manufacturing process. But this process has some limitations, high stress applications. Field orientation and raster angle have a big influence in mechanical properties of FDM manufactured parts, so engineers must pay attention. And hopefully, future is bright, because right now there are new advanced printers which can print long carbon fiber filament. Experimental approach. The goal was to investigate the effects of different field orientations and printing angles of impact specimens. Also compare PET G and PET G plus carbon. 30 specimens were tested for each material. There were 6 different types of specimens, which can be seen on the screen right. 3 different field orientations: flat, on edge, upright, and 2 printing direction angles, 0 and 90. Impact preparation. Impact testing was conducted on instrumented Sharpie Instron 9050 with sampling rate 1000 Hz. Main parameters can be seen on the right, and the most important parameter is potential energy of hammer, 5 joules. Specimens are made according to the standard ISO, and dimensions can be seen on the screen. Also, printing data like nozzle diameter, bottom temperature, heated bed temperature, speed, extrusion layer thickness, infill density, and overlapping can be seen on the screen. Results be seen here on this detailed graph for relation between force displacement, and this graph for energy and displacement. But for simplicity, we can use average values and get this graph. We can see that the best performer is EP, that is on-edge transfer specimen, and worst performer specimen is UP, upright transfers. The difference between those two is up to 600%. So with these results, we can see that different printing angles and orientations have a very big influence on mechanical characteristics. This graph can be presented purposely in this form here, so we can easily see does adding short carbon fibers have a big influence in achieving enhanced characteristics of material. Yes, we can see that, for example, for specimen L that is flat longitudinal, we have increase in 900%. Also, for case where is the best performer of PET G material, EP, increase is 200%, around 200%, and only decrease is in the case of UL, upright longitudinal. So we can conclude also FDM in both cases lead to very different results for different field orientation and different printing angles. But short carbon fibers improve mechanical characteristics. So now we can draw some conclusions. FDM is very useful production process, but there are some limitations. These limitations can be avoided because that is the nature of the FDM process. But in future development and new devices and new filaments, we can minimize those limitations and hopefully use that process for advanced industries. Engineers must pay attention to the orientation and raster angle, which is shown in this presentation. Short carbon fibers enhance structural integrity up to 900%, and in the best performer case for PET G, 200%, but is it enough? Probably not. So next generation devices with continual carbon fibers will lead to new opportunities for application in advanced industries. Future research is related to repeat all this process present here in this presentation and do that on different temperatures from cold to cryogenic environment. And that's it for today's presentation. Thank you for your time and attention.